Greetings, students. I welcome you all to another session of Circuit and System. And in today's lecture, we are going to start with graph theory. Okay. So these are the content for the topic. We'll go with the introduction of graph, what it is, important term associated with the graph, important matrices associated with graph, practice question which I'm trying that all the questions which have come in the previous examination should be there. So self-belief and hard work will always earn you success. That's what your favorite cricket icon, Mr. Virat Kohli, says. So keep self-believing, do hard work, you will surely succeed in the subject. Moving ahead. So, what is graph? Graph theory is provides a clear structural method for analyzing an electrical circuit. It also helps us to model and solve the complex problems efficiently. So basically, graph is a representation of a circuit in the form of branches and which helps us in analyzing the circuit in a very efficient manner. So currently, in this lecture, in the first part of the graph theory, we are much more concerned with how to construct the matrices, how to know what graph is, where the graph is built and everything. And in the second half, that is graph theory lecture 2, we'll be studying about solving for current and voltage equation using KVL and KCL. So let us just understand some basic things about the graph. So in graph, in our electrical network, we have resistor. Okay, we have an inductor, we have a capacitor, we have a voltage source, be it be AC, be it be DC, be it be shown like this. We have a current source. Okay, so in a graph, what we say whether it is a resistor, whether it's an inductor, whether it's a capacitor or a voltage source, or maybe series combination of all three or all four or out of two, we replace it with a branch. We replace it with a branch. So whether it is R, L, C, it will be represented as branch. Whether it is R, L, it will be represented as branch. Be it be a battery source, it will be represented as branch. But always remember, there is no representation for current source in graph theory. So we do not consider any branch for a simple current source. There will be no branch for the current source. So there will be a branch for resistor, inductor, capacitor, voltage source, AC, DC, or a battery, a combination of all two, combination of any two. But in any scenario, we won't have any branch for a current source. Is it clear, everyone? So moving ahead, so let us see how a graph is constructed. So basically, we have two types of graph. We have a non-oriented graph. We have a oriented graph. Okay, what is a non-oriented graph? A graph which does not have any current direction. We do not provide the direction of the current. So let us just consider this given circuit. Let us just mark this node as A, B, C. This whole line from here till here will have one node D. This is often known as datum node. Okay. So any other node which you can find out? No, we don't have any other node. Okay. So let us see what graph will look like. So from A to B, from A to B, we have a resistor connected. So we connect this. Wait, let me just draw it in a much more clearer way. So let us say from A to B, we have a resistor. From B to C, We again have a resistor. From A to C, we have a two capacitor and a resistor. So how many component it may be doesn't matter, but there is a branch existing. From B to D, there is a branch. From A to D, there is a voltage source. From C to D, there is an inductor and there is a current source as well. But as I said, there will be no branch for this current source. Now this forms a graph with 1, 2, 3, 4, 4 nodes A, B, C, D, 1, 2, 3, 4, 5, 6 branches. And if we provide the direction of the current. Now remember students, in graph theory, we can use any direction you want to use. From A to B, from B to A, from A to C, C to A, whatever you want. But always remember, once you have fixed the direction of the current, let us say I'm using these directions. Now, for further solutions, we cannot change the direction of the current at any point of the graph theory. Okay, so once we have given the direction of the current, this is stated as an oriented graph. When there was no current directions given to us, it was known as non-oriented graph. So that's how simple it is. Just remember, whatever way. So if somebody wants to say, okay, sir, I want to put direction of the current like this. Yes, you can always put it. The way you want to put the directions, you can always do that. Okay, there are no restrictions. But once you have put on the directions, that directions are fixed. You cannot change those directions. Okay, so moving ahead. So these are the basic terminologies which we use in the graph. Okay, so I'll just make a graph over here for your reference. That would make things easy. So I'll represent the nodes over here. So let's just make the graph which we got in the last example itself. So we have A, B, C, D. Okay, now, first of all, what is a node? Node is a point where two or more circuit elements meet, and node is a point where we apply KCL. Always remember this thing. Node is a point where we apply KCL. For example, let us just see an example. Okay, now here we have two elements connected. One is battery, other one is resistance. Okay, R1, R2, R3. Okay, here three elements are connected. Here two elements are connected, R1 and R3. Now, if you see, I've written node and a junction. So let us just first understand. See, every point is a node, but there's just a difference between node and a junction. If, let us see at this point, current is I. I'll just label it with I. Here current is I. Okay. Now, point is there any point of putting a KCL over here? No, because incoming current, outgoing current, straightforward. There's no change. But if I say at this very point, there is a requirement of current, KVL, because we have one incoming current. I've just put I2 and I'll put I3. We have two outgoing current. So we require to put KCL in order to know all the branch current. Here, whatever the current is coming. Okay, if I connect another resistor over here, then this becomes a node. So before that, if there is no resistor over here, this is a junction. This is a node. Again, this point is a junction because again, I2 is here, I2 is here. This point is a node. I'll not enter the other territory. That will be a problem for me. Okay, so this point is a node because current is coming from here, current is coming from here and going there. So the point where we apply KCL is a node. Junction is also a point where two or more elements meet, but we don't require to apply KCL in order to know the value of the current. So moving ahead, what is loop? Loop is a closed path which starts from one node, let us say from A, comes to the same node without repeating the node. So let us say this. So a current direction, it flows from A, goes to C, goes to D, come back to A. So it starts from A, it is coming back to A, but it hasn't repeated any node any time. Okay, so this becomes a loop. Okay, then we have a loop over here also. We have a loop over here also. We have a loop over here also. But this three smaller loop are known as mesh. What is mesh? Mesh is also a closed loop starting from the same node, coming back to the same node with no repeating node. But there's a difference between node and a mesh. When we come loop and a mesh. When we talk about loop, this was a bigger loop. It contained three mesh. But if I consider this mesh, if I take this mesh, if I talk about this mesh, the shaded mesh. Okay, we cannot have any other loop inside this mesh. So this becomes mesh. So what we can say, elementary loop is a mesh. Okay, now moving to a tree. So what is tree? So let us say we are considering this graph. Okay, I'll just make sure that you don't get confused. Okay, let us say this for this circuit I've constructed a graph. How many nodes we have? We have A, we have B, we have A, we have B, we have C, and we have D. Okay. Now, if I want to construct a tree, so simply a tree is a subgraph which contain all the nodes but no loop or any mesh. For example, let me connect this A with B, C, and D. So this is a tree. It has connected all the nodes, but there is not even a single loop. For example, I can use another way of connecting this tree. So let me just draw over here itself. Okay, wait. Chalo. Let me draw it over it here itself. A, B, C, D. This is also a tree. So we may have many ways to make a tree, but there's a limit. How many trees we can make? So total number of trees we can make out of a graph is a determinant of A and A transpose. What is A? A is an incident matrix. We'll be talking about this in the later half of the lecture. So next number of trees is determinant of A and A transpose. Now what's co-tree? Co-tree Co-tree is nothing but whatever is left out, whatever is left out of this tree, whatever branches we deleted to make this tree, whatever branches we made it, we deleted to make this tree. If we use those branches and we do not use this interconnection, this becomes my co-tree. So co-tree is nothing but co-tree is a subgraph which is formed by the branches that are removed while forming a tree. Hence, it is called as complement of a tree. So, dear students, you already know if what is complement. If we have 1, complement is 0. So, if we have use this, whatever left out is complement. Okay. For every tree, there will be a corresponding co-tree. And remember this thing, there is no such consideration for a co-tree that there should be a loop or mesh. Make it will contain a loop or a mesh. Okay, may not, will not, but there is no consideration for that. Now, what are twigs? Now, remember these terms. These terms are very important. So, what are twigs? These branches, these dark branches, which we have used to construct a tree. So these dark branches which we have used to construct a tree is known as twigs. So these dark branches are twigs. generally represented by solid lines. Then we have got links and chords. Links or chords. All those dotted line which were used to make code tree, or we can say which are left out when we have constructed a tree, is known as links or chords. So branches of code tree are called links or chords. These are generally represented by dotted lines. Okay. So solid lines for tree, for twigs, dotted lines for links. Okay. So I hope you all remember. Now hope you will remember these terms. Twigs, branches of tree; links or chord, branches of core tree. Tree will not have any loop. Core tree may have loop. Okay. So let us see. Let's move ahead. Let us understand the matrices. So in graph theory, we have three major matrices. One is incidence matrix, other one is a tie-set matrix, and the last one is a Q matrix. So we'll consider one simple graph. We'll take the same graph again. Okay. Okay. It's an oriented graph. So I've just made myself clear. Okay, let's just draw solid lines first. Okay. So I've given the directions of the current. Let's put this as node A, node B, node C, node D. So this branch is 1, 2, 3, 4, 5, and 6. So we have 4 nodes and 6 branches. So what is an incident matrix? Incident matrix A will have all the nodes A. Okay, let's just put it as small letters so that it doesn't confuse you. Okay, so A, B, C, D. All the branches will be listed over here. 1, 2, 3, 4, 5, 6. So we have 6 branches, 4 nodes. So see carefully. We'll start with node A. We'll start with node A. Okay. So if a branch is incoming, we'll replace it by, we'll put the number -1. Okay, let me just put that. And if the branch, the current is outgoing from that node, we'll replace it by 1. So at node A, we have 3 branches connected, 1, 2, and 6, where 1 is an incoming branch, 2 and 6 are outgoing branch. 1, 2, and 6. This is 6. Okay, so we have 1 as incoming branch, so I'll put it as -1, 2 as outgoing branch, 6 as outgoing branch, and rest all are not connected, are not associated. I'll put it as zeros. So all the branches which are not associated with that node, will put it as 0. Okay, so at node B, 1 is not connected, 2 is an incoming branch, 3 is an outgoing branch, 4 is an outgoing branch, 5 is not connected, 6 is not connected. At node C, 4 is an incoming branch, 5 is an outgoing branch, 6 is an incoming branch, 1, 2, and 3, or rather 3 to 1 are not connected with C. So at node D, 1 is an outgoing branch, 2 is not connected, 3 is an incoming branch, 4 is not connected, 5 is an incoming branch, 6 is not connected. So this is my A incidence matrix, and I generally denote it as AC. It is a complete incidence matrix. So there is a property about this matrix. So when I've written C, when I've just specifically denoted it as AC, complete incident matrix, just look at this D. Now, I'm just plotting this dotted line. If you will see, sum of each column will be 0. -1 plus 1, 0. -1 plus 1, 0. minus 1 plus 1, 0, 0, 0, and 0. So this property of incident matrix, just take a screenshot of it first so that I can go ahead and start my work over here. So there is a property that sum of the column will be 0. So I can always have an other incomplete incident matrix where where I'll say I won't be requiring this D. I'll just give you an ABC and will expect that D can be plotted by just using the property that sum of the column will be 0. So this is my incident matrix. Next matrix is my tie set matrix, or we also call it as F loop, fundamental loop matrix. So what for this? We require a tree. So remember one thing, we can make a tree whatever way you want, but I just have a suggestion. Okay, consider this whole graph as an island surrounded by water. Okay, now remove all the branches which are being touched by the water. So I don't need 1, I don't need 5, I don't need 6, and left out will be less. So this is 2, 4, 3. So this becomes my tree. Okay. So we have a tree. Obviously, we'll have a core tree. So need to plot the core tree as well. This is an outgoing. Do not change the direction of the current, as I've already told you. What may come once you have decided the direction of the current, never change those directions. So this is 4. Okay. Now, what is a tie set matrix? So number of tie set will be equal to number of links. What are links? The branches of my core tree. So number of tie sets will be equal to number of links, and number of links will be equal to number of, or rather just leave it. Remember this thing, don't get confused. So we need number of links. So let us just make a tie set matrix. How many links do we have over here? We have 4, 5, 6 as links. So just remember, first write the twigs in the increasing order, 2, 3, 4. And what are the links left out? Okay, I've just labeled something wrong. Okay, this is 1. Sorry. We have 1, we have 5, and we have 6. Okay, so this matrix is known as B matrix. So we'll just write down the tie set. So as I've told you, tie set will be identified by number of links. Okay, so what is the first link? We have got 1. Okay, what are the twigs associated with it? 2 and 3. Okay, I'll just make sure I use the right combination so that you don't get confused. So I have a link 1, I have twigs 2 and 3 associated with it. So take any node. Let us say for this particular tie set, I'm taking this, considering this node. Okay, so we have got A, B, C, D. Okay, consider this node, start moving in this direction. This becomes my loop. Start moving in this direction. 1 is an outgoing direction. Place it as 1. So always remember, whatever tie set you are choosing, choose the direction according to the link. Okay, so direction will be according to the link. So start with D. 1 is in same direction, 2 is also going in the same direction, 3 is also going in the same direction, and 4 is not connected to it. Okay, so we have the link tie set for this is 1 1 0 1 1 0 1 0 0. 2 3 are connected and in the same direction of the current. 4 is not connected, 1 is in the same direction of the current. So next tie set would be 5 4 and 3. So if it is 5 4 and 3, so 2 will be automatically 0. So let us start with this. We have a direction of the current according to the 5. Let us start with this C. So we have 5 will be in favor. Okay. 3 going against. 4 is in favor. Okay. So I hope the correct direction of the current is quite clear to you. Simply choose the link and make the directions of the current according to the direction of the link current. So over here, let us start with this. So we have a link with 6, 2 and 4 connected to it. So we'll start from point A. 6 is in favor. So 6, always remember direction of the current link will be favored. 6 and moving ahead. 4 is in against direction, moving till this node. 2 is in against direction. We have got our tie set matrix. Okay, clear everyone? In the subsequent examples, you will get to know how to make this tie set matrix again. Just remember, choose a tie set, put the direction, choose a node, start rotating it in the direction of the link you have chosen, right? So this is my tie set matrix. Next is cut set matrix. Okay, let me just adjust some space for you. Okay, so cut set matrix. So what is cut set matrix? Cut set matrix is number of cut set is equals to number of twigs. Twigs, you know, branches of tree. Okay, so number of cut sets would be number of trees. So in a cut set matrix, we have to make sure that there is only one twig. It can have multiple links in it. One twig and multiple links. Okay, so let us just try to form the cut set. Let us see. Let's make this graph again for you. One, two, three, no, four, four, three, 3, 4, 5 and 6. Okay, so we have the same graph we are using. Now, let's say Q cut set matrix. So I'll just put this as Q1. How many twigs we have? We have 3. So we'll be having 3 cut set. Okay. So what are the twigs into it? 2, 3 and 4 are twigs. And we have 1, 5, 6 as links. So my first cut set would be, let us consider the second branch and I draw this line over here. Okay, so whatever links it has cut will be associated in this cut set. So this cut set will be identified by 2 and what all links it has cut? 1 and 6. 1 and 6. So 2 will be 1, 3 and 4 will be zeros. Okay, so direction of the current at this node is going outside. So whatever the direction of the twig is, If link follows the same direction, then it would be marked as +1. If the link is following some other direction, it would be marked as -1. So 2 at node A is going out, 6 is going out, but 1 is coming in. So this will be the my cut set matrix. So 2 is going out, 6 is going out, 1 is coming in. 2 and 6 follow the same direction, 1 follow the different direction. Next twig. Oh, sorry, next cut set. Twig I'm using is 4. This is going to be my cut set. Cut set is basically dividing the graph into two halves. Okay, so using 4, it has cut a 6. Okay, sorry, it has cut a 6, it has cut a 5. So, okay, we have a cut set over here also. Sorry, we'll go in the order. We'll let you know why. So we have 3. I'll just put it again. So we have 3, we have 1, and we have 5. So 3 will have the direction 1. So whatever is the name of that cut set, if we are using the twig 3, put it as +1. So according to the direction of 3, the direction of the other two links will be decided. So 3 is incoming to the node, 5 is incoming to the node, but 1 is outgoing. So 1 which is outgoing has a different direction, 5 has the same direction, and 6 has a different. 6 is not connected in this. So similarly, now we'll go to 4, 5 and 6. Okay. So 4 has a direction which will be incoming. So now incoming direction is 1. 6 has an incoming direction. 5 has an outgoing direction. And 1 is not connected to it. So this becomes my cut set matrix. Now, if you see it carefully, this matrix and this matrix, this part of the matrix. So what I can say is my tie-set matrix, this is an important thing. Tie-set matrix B can be determined as BT, that is matrix of twigs, and UL, which is identity matrix of all the links. So remember this thing. My tie-set matrix will have a matrix of BT and identity matrix UL of all the links. Similarly, my cut set matrix Q is nothing but UT, unit matrix of twigs, with QL, cut set matrix of links. Okay, these are my 3 matrices which I require to solve the graph theory. Okay, which came in GGSIPU 2015 exam. Okay, so generally for 99% case will have the similar type of question, that where they'll be asking you to identify the tie set matrix, write down the tie set schedule, identify the identity matrix, write down the identity schedule. Okay, so for this question we'll be using all the 3 matrices. First, let us just write. They have just asked us for the tie set matrix, but for the practice case we'll be going with all the 3 matrices. So let us write first A matrix, incident matrix. So they have already given the direction of the current. If you'll see, they've already provided us with the direction of the current. If these are not visible clearly, I'll say this is 1, 2, 3, 4, 5 and 6. These are the numbers. Okay, so for A matrix, that is my identity matrix, 1, I not identity, incidence matrix, 2, 3, 4, 5, 6. How many branches we have? How many nodes we have? We have A, B, and C node. So let us say at node A, let us see at node A, we have 4 connected to it, 1 connected to it, 2 connected to it, and 5 connected to it. 1 and 4 are incoming currents, 2 and 5 are outgoing current. So 1 and 4 are incoming, 2 and 5 are outgoing, 3 and 6 are not connected. At node B, 5 and 2 are incoming, 3 and 6 are outgoing. So 5 and 2 are incoming, 3 and 6 are outgoing. Rest all is not connected. At node C, 3, 6 incoming, 4, 1 outgoing. Okay. Now again, let us just check out the properties which I just said to you. Sum is 0, 0, 0, 0, 0, 0. Hence proved that sum of each column of incidence matrix will always be 0. So for making a tie set, first we need to make a graph out, a tree out of this graph. So again, we can use the water theory. If this is a water body, let us remove 4, 5, and 6. So even if I remove 4, 5, and 6, still there'll be a loop into it. So I'll just consider now it's my wish. I can remove 1, I can remove 2, I can remove 3, any other branch I want to remove. So I'll just take this thing as graph, my tree. So I've just taken 2 branches in the tree. That is 1, and I've taken 3. So it connects all the 3 nodes and there is no loop formation. Rest all is my chords, or we call it as links. So we have 4, we have 5, we have 2, and we have 6. So now they've asked us for tie set, P matrix. So how many tie sets will be having? Number of tie sets will be equal to number of links. So just write down first the twigs. Twigs are 1 and 3. Links are 2, 4, 5, and 6. So tie sets. So we'll be having a tie set with 2, we'll be having a tie set with 4, we'll be having a tie set with 5, we'll be having a tie set with 6. Okay. So when I join this 2, I have a loop formed over here. So this is my first tie set which will contain 2, 1, and 3. So direction of the 2, take any point. Direction of the 2 from this point is going out. So put it as 1, 4, 5, 6 will not be required. Direction of 3 is in favor. For completing the loop, direction of 1 is also in favor. So this becomes my first tie set. Now I've joined 4. 4 and 1, just 2 are required. So 3 is not required over here. So at this point, 4 is going out. For completing the loop, this is A, B, C. For completing the loop from this point, 4 is going out. If I come this side, it has got an opposite direction. So 4 is 1 for sure, but 1, the current of 1 is in opposite direction of the loop. Okay, moving on to the other loop. If I connect 5, then I'll be having 5, 1 and 3. So I'll start from this node A, 5, 3 and 1. All are in one direction of the loop. So 1, 1, 0, 0, 5 is 1, 6 is 0. Let's go with the last one. 6, 6 and 3. So 1 is not required. 3 is in opposite direction of 6. This is my, these are my tie set and these are my tie set schedule. So the question next arises is, can we write a cut set matrix for us? So cut set matrix Q would be given by how many cut set? Number of twigs we have. So let's just make it. They didn't ask us. We'll just, for practice sake, we'll just write down the cut sets. So we have one, two, and then we'll be having 4, 5. No, 1 and 3 as cut sets. 1, 1, 3, 2, 4, 5, 6. Okay. So we just have 2 twigs. So we'll be requiring only 2 cut sets. So 1 at this point, it requires only 1 at this point. So this will be 1, it is cutting 4, it is cutting 2, it is cutting 5. So 1, 4, 2, 5, 1, 0, and then we'll have 3, it will be cutting, no, I've already cut it. So for 3, we'll have 2, 5, and 6. So just check out the direction of 1, current 1. So current 1 is incoming, 4 is incoming, 2 is outgoing. Just return it down. So 4, 1 is incoming, 4 is incoming, 2 is outgoing, 5 is outgoing, 6 is not connected, so it's a 0. Again, for this point, 3 is outgoing, 6 is outgoing, then 2 is incoming, 5 is incoming, and 4 is not connected to it. So this becomes my cut set matrix. Although it is not asked, we have just made it once again. Moving ahead to the next type of question. Next type of question is, this was recently asked in June into 2019 in GGSIPU final exam. They've given us an incident matrix. They want us to draw the graph. They want us to draw its tree and then find out tree cut set and tie set matrix. Okay, so let us just do one thing. This they have given it as A. So first thing first, we have to make it as AC, that is the complete incident matrix. So whatever they have given us is 0, 0, 1, 1, 1, 0, minus 1, 0, minus 1, 1, 0, 0, minus 1, 0, 0, minus 1, 1, minus 1, 1, 0. So to complete this, we need plus 1, minus 1, we don't need any branch over here, minus 1, 0, 0, and 0. So let us consider this as 4 nodes, A, B, C, D. Now, if you want to construct a graph, see, graph is a tree is not unique. Graph, the way nodes are connected is going to be unique, but you can make different designs. You can put A, B, C, D anywhere you want. But I'll just suggest you start forming this way. We have 2 nodes. Put this D as datum nodes over here. Put it as A, B, and C. Okay. Now see, we have this first thing. In the first branch would be C and D are connected in a first branch in a manner that C is incoming and for D it is an outgoing. That is why the direction of the current I have considered -1 as incoming current, +1 as outgoing current. Again, my branch 2 would be B connected to D. So B and D are connected. For D, it is an incoming current. For B, it is an outgoing current. Similarly, my branch 3, this is the connection of A and C. Connection of A and C. A, it is an incoming current. C, it is an outgoing current. Okay, right. Okay, branch 4, it is a connection of A and D. For D, it is an incoming current. For A, it is an outgoing current. Branch 5, A and B are connected. For B, it is an incoming current. For A, it is an outgoing current. For branch 6, it is C and B. For C, it is incoming. And for B, it is outgoing. Then there is a branch 7 also associated with it, which is A and B. From B to A, it is branch 7. So we have 1, 2, 3. 3 is, no, I forgot to mention the numbers. So this is my third. This is my A to D is fourth. This is fifth. This is sixth, and this is seventh. So this is my graph. Let's go through it once again. You'll be able to identify it. Okay. See, first branch is C and D. C and D are connected. For C incoming, D outgoing. Similarly, I've got all the branches. So if you will see, this will form its tree. Okay. And then this all will be my twigs and links. So direction of the current is already given. That's why. Okay. So I would request you all, this you can always try and practice to form my tree and its identity and loop and cut set matrix. Okay. So just try it once. If you don't get it, put it in the comments. I'll provide you with the solution of it. Okay. So whosoever comments it will get the solution for this. Okay. Now, again, this is a very famous question. This question has come many a times. Then they've asked different stats related to this question. At times they're given the values. At times they're given the resistors, the inductors, and they've asked us to find out the KVL and KCL equation. But in 2016, they just asked us to determine its identity matrix, its tie-set matrix, and its cut-set matrix. So, and they have given us a thing that my twigs will be 4, 5, and 6. So they have already given you an ample time to decide what your tree would be. So let us just start with matrix A. We'll go quickly, will not waste much of time in explaining. Okay, so we have got 3 branches, 3 nodes A, B, C, and another node over here, that is D. So how many branches we have? We have 1, 2, 3, 4, 5, 6 branches. So we have 1, 2, 3, 4, 5, 6. Any other thing? No. So for at point A, branch 1 is outgoing. So for A, branch 1 is outgoing. For B, branch 1 is incoming. So I'll just make it quickly from A to B. Okay. From A to D. For A, it is incoming. Okay. I'll just. Okay. So for first branch, second branch is at B. For B, 2 is outgoing. Okay, I've just, sorry, by mistake, okay, let's go with this flow again. For A, 1 is outgoing. Okay, 6 is incoming. 3 is incoming. 2 has got no relation with A. And 4 and 5 has got no relation with A. Okay, at point B, 1 is incoming, so I'll just place that over there. 2 is outgoing, 4 is outgoing, 5 is outgoing, 6 is not associated with it, 3 is not associated with it. So at point C, 1 is not associated, 2 is incoming, 5 is incoming, 3 is outgoing, 4 has got no association, 6 has got no association. For D, I can always, I'm not going to skip this part with the graph. 1, 1, 0, 0. Here we require -1 to make this 0, -1. So at D, have I written something wrong? 4th is incoming, -1. 5 is outgoing. So at C, 5 has got its relation. At B, 5 will be 0. This is a mistake. So see, that's how properties help you out. That's how properties help you out. Okay. So this is a clear case. That's where your properties are helping you out. So now, so we have 4, 5, 6. We have 1, 2, and 3. So my tie-set matrix, that is B, number of links decides my tie sets. So we have twigs as 4, 5, 6, links as 1, 2, and 3. So just we already know this is going to be my identity matrix. So let's just finalize it. Let's do it with the way we can quickly do it in exam. So we have got, if I connect my first link, so my loop will be 1, 4, and 5. So I'll start from this point. 1, 4 is also in favor, 5 is also in favor. 1, 5, this is not required. So I'll put this thing over here. So I'll have 2, 4, and 6. I'll go in this direction. 2 is in favor, 6 is not in favor, 4 is certainly not in favor. Okay, next will be 3, and connected would be 5 and 6. So we'll start from this point. 3 is in favor, obviously. 5 is out of favor, and 6 is in favor. So this becomes my tie-set matrix. Let's go with the cut-set matrix quickly. So cut-set matrix Q will be determined by number of twigs we have. So 4. So this is first cut set, second cut set, and third cut set. So first cut set would be 4, 1, 2. Then it would be 5, 1, and 3. Then it would be 6, 3, and 2. Okay. So 4, 1, and 2. So direction of 4, 5, 6 will be unity. So with the direction of 4 at this node is coming in or going out. 1 is in, 2 is out. So 1 is in, 2 is out. Okay. So this is according to the direction of the twig we have used. So in this case, at 5, it is incoming. 4 is outgoing. 3 is incoming. Oh, 1 is outgoing. 3 is incoming. It's this. 6, 3 and 2. 6 and 2 are in same direction. 3 is in other direction. So 1 is not required. 6 and 2 are in same direction. And 3 is in other direction. So this is my tie set, cut set, and identity matrix. It's not identity matrix, it's incidence matrix. So pardon for this mistake. So it's incident matrix, tie set matrix, and cut set matrix. So this is all about your graph theory. I hope I made you understand all the three types of graph. For any doubts, do write in the comment section. And always remember this thing, grain of sand builds a mountain. छोटे छोटे तिनकों से ही पहाड़ बनता है. Please Do like, share, and subscribe the channel and let this universe expand. Okay, keep studying, work hard. Thank you.